Good morning, students. Today we are going to cover the second application of dimensional analysis, that is the deducing relation among the physical quantities. We already studied the first application of dimensional analysis. The first application is what? To check whether the equation is dimensionally correct or not. It is related to homogeneity principle. Now see second application, that is the deducing relation among the physical quantities. For that we are taking here the example 2.17 from your textbook. Consider simple pendulum having bob attached to string that oscillate under action of force of gravity. See, it is a string and here this metal ball that we are considering, it is bob. It oscillates under the action of force of gravity. Suppose that the period of oscillation of simple pendulum is depends on. Period means what? The time taken by particle to complete one oscillation. So this period of oscillation is depends on here three things. The first is its length, second is the mass of bob, and third it is the acceleration due to gravity. Okay, so here the time period is depends upon these three things. Derive expression it's for its time period using method of dimensions. So you have to know first the time period. It is depends upon three things, that is the L, G and M. Okay, so here we can write the equation for it. T is equals to L raised to X, G raised to Y and M raised to Z. Why we have written this equation? Because we are going to find the relation between the physical quantity. We don't know what is a X, what is a Y, what is a Z, and that we will find here. So we have to take here constant, that K is dimensional constant. So see here we have written this equation. T is equals to K, L raised to X, G raised to Y and M raised to Z. Now we have to put its dimensions. Listen, already you know that the dimensions of T. What is this? L raised to 0, M raised to 0, T raised to 1. K is as it is. For a length, what are the dimensions? L raised to 1, M raised to 0, T raised to 0, raised to X. Okay, same like that for G we are writing the dimensions of acceleration, and that you know already. See, L raised to 1, M raised to 0, T raised to minus 2, raised to what here? Y. And for M stands for mass. So you know also the dimensions of it. L raised to what here? 0, M raised to 1, T raised to 0, raised to Z. So we have written all this quantity in the form of dimensions. Let us see here. L raised to 0, M raised to 0, T raised to 1, L raised to 1, M raised to 0, T raised to 0, raised to X. This is raised to Y, and for M we are writing here L raised to 0, M raised to 1, T raised to 0, raised to Z. Okay. So K is dimensional constant. What we have to do now? See the first term, L raised to 1, M raised to 0, T raised to 0. What is a present here? The X is a present. Okay. So how can we write it? 1 into X is what? L raised to X. 0 into X, 0. T raised to 0 into X is 0. Okay. So here we are writing only the L raised to X, isn't it? Next, L raised to 1 into Y. 1 into Y is what? L raised to Y. M raised to 0 into Y. 0 into Y is 0. T raised to minus 2 into Y. T raised to minus 2Y you can write. Next, L raised to 0 into Z it is. M raised to 1 into Z. What is this? M raised to Z. T raised to 0 into Z. That is 0. And this term I am taking as it is. that is L raised to 0, M raised to 0, T raised to 1. Just we have multiplied by here X, by Y and by Z. See here, how can we write the equation for L? L raised to X, and what is the present here? L raised to Y. You know the rule. How can we write it? L raised to X plus Y. Clear? Know this. A raised to M into A raised to N is equals to A raised to M plus N. So we have used it. Next is what? T raised to minus 2Y you can write. M raised to Z first we will take, because our sequence is L, M, T. So I am taking M first. M raised to Z. Next is what? T raised to minus 2Y. And this is as it is I am taking L raised to 0, M raised to 0, T raised to 1. See? This is L, this is L. So we can equate these equations. How can we write it? X plus Y is equals to 0. This is M, this is M. Z is equals to 0. This is T, this is T. So minus 2Y is equals to 1. So we can find out the values of X, Y, Z with the help of it. So what is the value of it? Minus 2Y is equals to 1. Therefore Y is equals to, how can we write it? Minus 1 by 2. We have got the value of Y. We can find out the value of X. So put the value of Y in equation number 1. So here X plus, I am putting the value of Y directly here. Otherwise I will write Y is equals to 0 and put the value of Y. X minus half is equals to 0. Therefore we have got X is equals to what? Half. So see here, we have got all the values. X is half, Y is minus half, and Z it is already present here, it is 0. So we can write the values of X, Y, Z in our relation. See, what is this relation? T is equals to K, L raised to X, G raised to Y, M raised to Z. So T is equals to, K is a dimensionally constant, you know it. L raised to, what is X? Half. G raised to minus half. And M raised to 0. 0 means what? M raised to 0 is what? 1. So we will not write it. Okay. So we have got this relation. How can we write this relation? K is constant. We are taking it as it is. L raised to half means we can write in square root. So L is here. G raised to what here? Minus half. So it will be at a denominator. So we have got this relation, that is T is equals to K root of L upon G. So we have seen here the relation for a time period, and if you will put the value of K is 2 pi, what will be this relation? That is 2 pi root of L upon G. We have taken K is what here? 2 pi, and this is the formula for a time period. So here we have taken the second application of dimensional analysis, and this is the last part of this lesson. We have seen already the 2 applications of dimensional analysis. So you will revise this problem 2.17 and try to solve in your notebook. Thank you.